Hello, this video is supposed to help you on Unit 5, Lesson 5, Core Focus Measuring Volume. And if you stay for the explanation for all three problems, which you can find in your student guide, there will also be an extra credit problem at the end that you can K-mail me and get extra credit towards your math grade. This first question here on your student guide says, how many fractional unit cubes with side lengths of 1/3 foot are needed to fill a unit cube with side lengths of 1 foot? What is the volume of the 1/3 foot cube, and explain? So there's two different questions there, and you know I like to add the visual element for those of you who are visual learners. So here we have a 1 foot cubed, 1 foot by 1 foot by 1 foot, and this little cube is 1/3 of the size of that big cube. Each side is 1/3 of the size of it, and the length, width, and height are all 1/3 of the side. So the question is asking us how many of these little cubes could fit inside of this cube right here. And so if you think about how many could you fit down on the bottom, if we were just going with the length here, we could fit 3 across, and then it's going to be a little hard to kind of draw this three-dimensionally, but on the bottom, how many do you think we could fit? And then as we stack them up and fill it in, how many do you think we can fit? So we're going to kind of work on the volume in order to answer that first question, but I'd like to start first by finding the volume of the little cube. So if you remember, volume is length times width times height, and so for the little cube, that's substituting in the 1/3, 1/3, and 1/3. If you multiply those numerators, you get 1 times 1 times 1, and that's 1. And if you multiply the denominators, 3 times 3 is 9, times 3 is 27. So that little cube has a volume of 1/26 foot cubed. So that is the answer to the second question. So basically what that's saying is this has 1/27th of this volume is what it would take to have the volume of this one. And so working backwards with that, well, how many of those little ones could we fit in there? Well, we know on the bottom we could fit 9 of them, and I know my picture is just awful. But if you kind of think about, we could fit 1, 2, 3, and then 1, 2, 3 along the front, and that 3 times 3 would give us 9 for the area of that base, because they're 1/3. And then if we stack that 3 high, we would get 27. And so how many little cubes does it take to fill up the big cube? That would be 27 of them. And that is what they're asking you on that first question. Let's look at the second one together. It says Rosario's fish tank is in the shape of a rectangular prism. The tank is 40.5 centimeters long, 25 2/5 centimeters wide, and 30 centimeters deep. What is the volume of water needed to fill Rosario's fish tank? And so when I went on to Google adding this visual element, I saw all sorts of cool fish tanks. There was this one that looks like the banister of a staircase. There was another one that was the back of a toilet. That was interesting. But I decided that for us, we just needed to go with a simple outline of a fish tank, a rectangular prism, so that we could really visualize what they're talking about. So it's telling us that it's 40.5 feet long, or centimeters long, excuse me, and 25 2/5 wide, and then 30 deep or tall, meaning deep as in how deep the water is. And so again, the volume is figured out by length times width times height. So we're going to go ahead and find the area of the base first, because that's what we were working on the previous lesson. We're going to do the 40.5 times 25 2/5 first. I want you to pause the recording and get your, change these into improper fractions, and then unpause the recording and come back and see if you got the same answer as I did. Go ahead and pause the recording now. All right, you should have changed those into improper fractions. That way you're ready to do the multiplication. Let me show you what those are. 81 over 2 and 127 over 5. Remember, the way we do that is 20 times 40 plus 1. That gives us the 81. 5 times 25 is 125 plus 2. That gives us 127. Now we need to multiply straight across on both the numerators and the denominators in order to get our multiplication over here. Go ahead and do that. Pause the recording and then check your answer. Okay, if you used your handy dandy calculator and did that math, you should have 10,287 on the top and 10 on the bottom. The next step would be to multiply this area of the base by the height or the depth of this fish tank. So I'm going to go ahead and work that up here, and just let me copy our little area right here and move it up, and then we're going to times it by 30, and to make it a little bit easier, I'm going to do it 30 over 1. I'm going to just take that whole number and make it a fraction so we can multiply our numerators and our denominators. So as you're multiplying that, see if you can use cross multiplication at all to help you come up with a simpler answer right from the start. Okay, hopefully you were able to get that multiplied out. Let me show you what I did. I did that cross multiplying beforehand, and so I knew that 10 and 30 shared the common factor of 10. So I divided 10 by 10 and got 1. I divided 30 by 10 and got 3. Then I multiplied this 10,287 by 3 and got 30,861. Then I multiplied my denominators. That was simple, and I got 1. And so I didn't have to do any reducing at the end. If you had left it as 30, then you would have gotten a bigger numerator here and would have had to simplify it by 10 in order to get to this answer, or divide it by 10. And so your way might have taken you an extra step. So at this point, I know that the volume inside of this fish tank was 30,861 centimeters cubed. Let me add that cubed on there. And that is the answer. I'm going to circle it. There we go. All right, let's try the last problem together. The last problem says, the figure shows a cement block with a 1/4 foot square hole bored through the center of the block. Determine the volume of cement in the block. So they want the volume without that hole there. So first we have to find the volume. Then we have to find the volume of this hole that they bored through and subtract that from the overall volume. So we've got a couple steps on this one. Let's start by finding the volume of the cement block. Do you know how we do that? Remember, volume is length times width times height. So let's use substitution. We have 1 1/4. Let me move this little color thing out of the way. Times 2 3/4. Times the height, which is 1 1/2. So all of those multiplied together. Well, before we do the multiplication, we learned in the last unit that we're going to want to turn them into improper fractions. Remember, the way you do that is you multiply the denominator by the whole number and then add in the extra that's up there in the numerator. So go ahead and pause the recording, do that math, and then you can check it with what I've come up. All right, so hopefully you got those figured out. Let's check how you did. When I turned them into improper fractions, I got 5/4, because I went 4 times 1 plus 1 is 5 over 4. I got 2 3/4 turned into 11/4. 4 times 2 is 8, 9, 10, 11. Keep the denominator the same. Then 2 times 1 is 2, plus 1 is 3 over 2. I hope that's what you got too. Now we can multiply, but first we want to say, is there any common factor that the numerators share with the denominator that would make it simpler? And I don't really see any. One thing that I'm doing differently than the last problem is I'm multiplying all three numbers together at one time. We could have first done these and then multiplied that answer by this one, which is what they show you in your student guide. But I'm going to go ahead and do them all three at the same time to get that overall volume. All right. So go ahead and do your multiplication. Pause the video and multiply your numerators and multiply your denominators, and let's see what you get. All right, if you did that multiplication, you should have got 165 over 32. The next step would be to turn that into a mixed number. You could wait to do that until you finish the whole problem, or you could do that now. Remembering that our next step is to find the volume of this center square hole and then take it away from this overall volume. So I'm going to go ahead and turn this into improper fraction now, and then we'll be able to work with it, I think, a little bit easier. So if you remember to turn a mixed or an improper fraction into a mixed number, I think I said that backwards, you want to do a division like this. So go ahead and pause the recording and do your division and tell me what this would be as a mixed number. All right, if you did that math, let's take a look. I got the whole number 5 and 532. And here's the math from that one where I went 32 times 5, got me 160. There's my remainder, which I put over the top of my divisor. So what I just figured out was the volume for this whole cement block, but it still has it as though there's not a hole in it. So I want to find out what that hole would be. The hole, again, is going to be a volume, length, times width, times height. The length for that one, we're going to say is 1/4, and the width of it is 1/4 of a foot, and the height, and remember those terms are kind of interchangeable as long as we get all three of them. So I've done these two here. Now we're going to take what I would actually call the length because it's longer, but it's that 2 3/4 measurement is that last measurement there. And so depending on if the shape was sitting up on its base or whether it was laying the way it is, it doesn't really matter which way you term it, as long as you get all three dimensions multiplying together. So we need to do this last multiplication here. Remember, the first step is to turn it into an improper fraction and then to multiply. So go ahead and pause the recording, turn this into an improper fraction here, and then unpause. All right, let's see how you did. If I change that 2 3/4 into an improper fraction, it's 11/4. There's 2 times 4 is 8, 9, 10, 11/4. The last step is to multiply your numerators, multiply your denominators. So 1 times 1 times 11 is 11. And then 4 times 4 times 4, go ahead and do that math. 64. All right, so the volume of that little hole that they bored is 11/64 of a foot. The last and final step, I'm going to change my pen color for this last step since my board's getting kind of full, is to subtract that 5 and 532, subtract the 11/64 out of that. So remember when you're subtracting that you need to change the bottoms so that you're comparing apples to apples, or 64ths and 32ths into equivalent fractions, so they have similar denominators. And then there's another step where you want to make sure that you have enough in this numerator to subtract this. You might have to borrow from your mixed number. Go ahead and pause the recording and give that a try. Okay, if you change this into 64ths by doubling the denominator and then doubling the numerator, you would have got 5 and 10/64 as the equivalent fraction. Now we're ready to take 11 away from 10. Whoa, wait, we can't do that. What do we need to do? We need to change this into 4 and borrow 64/64. So that would make this 74, because we're adding that 64 that we cut that whole number up into. And then now we can take away the 11. Go ahead and try that. All right, I hope you pause that. Here's the answer. We get 4 and 63/64.